Okay, here we go. Here's a short video about circles and the angles that we find in circles. And just to prove to you that we definitely need to know about this, we have something like this pie chart, or we call it sometimes a circle graph. So we know that we're dealing with circles a lot, and that circles do have angles, and that we need to know about those angles and so forth. The most important thing to know about circles that we should remember from a long time ago is that there's 360 degrees in each circle. Sorry about the messy handwriting. And that includes 360 degrees around this way and 360 degrees all the way around the outside of the circle, back to the beginning here. All right, so let's deal with some circles here. First, some vocabulary. We talk about the arc measure. Well, an arc is going to be the outside of a circle. So an arc is going to be from, say, A to B. This is going to be an arc. And an arc measure is just going to be something given in degrees. So I might say something like arc A to B is equal to, let's say that looks like about 45 degrees. Okay? I put this little symbol on top to say that I'm talking about an arc. We have a couple different types of arcs. A minor arc is going to always be less than 180 degrees. So A to B is a good example of a minor arc because that's less than 180 degrees. A major arc is going to be greater than 80 degrees. And so we usually label a major arc with 3 points so that we can say which way we're going. Because if I wanted to say, let me use a different color, that my arc was from A to C, what I would have to do is put in another point to distinguish between A to C on the top way or A to C the bottom way. So I might say something like, I'm talking about arc A to E to C. So that means I'm going all the way around this way. That's going to be greater than 180 degrees. The diameter, of course, goes right through the center of the circle, so the diameter of this circle is A to D, and that's a line, so we put a line on top. And then the central angle is any angle where the vertex, okay, the vertex of the angle is at the center of the circle. Okay, so I might say angle, so this is our indication that we have an angle B to O to C, B to O to C, and we always put where the vertex is in the center of how we describe our angles. Angle BOC is a central angle. Now, what's important about this is that a central angle has equal measure to what we call the arc, okay, that it's indicated. So if I say this is 30 degrees here, then this is 30 degrees from B to C. So BOC, angle BOC equals 30 degrees, and that's also equal to arc B to C. Okay? Okay, next page. I promise this will be short. So if we have a couple examples here, you know, if this is going through the center of the circle, then we know that this whole thing has to be 180 degrees, or these three angles together have to be 180 degrees. Well, there's 100 degrees, and if x and x indicate that they're both x, that means they have to be the same. So I have to split 80 degrees evenly, so I know that that's 40 degrees and that's 40 degrees. And we just said that the angle, if its center is at the, if its vertex is at the center, and its arc are the same, so in this case, y equals 40 degrees. That's just an arc y. Here, going back to some vocab from the first video, two lines are split, so this is going to be 50 degrees here. Those are vertical angles. almost vertical angles. We'll go with it for now. And so if that's 50 degrees, then that arc has to be 50 degrees as well. Here, going backwards a little bit, if it's 330 from here to here, then we know this has to be 30 degrees out here, because 30 and 330 is that 360 degrees that we need. And so then my y equals 30 degrees as well, because that is at the center, and those are going to be equal. Slightly different, and hopefully you can see why, when we have an angle where the vertex is not at the center, here's the center, but the vertex is on the edge, then that's called an inscribed angle, versus a central angle was when the vertex is at the center. So an inscribed angle, the vertex is at the edge of the circle. Okay? And so the intercepted arc in this case is the arc created by an inscribed angle. So this is the special arc in this case. This is the special angle. And here's the special relationship. The arc is going to be 2 times the angle. The arc, an intercepted arc, is going to be 2 times whatever the measure of the inscribed angle. So in this case, if this is 45 degrees down here, then this arc is 90 degrees. Or if you let me do one more example, we'll just do this one quickly. Let's say we have this. Wow, that's not a straight line. Let's say this is 110 degrees out here. Hopefully you're saying in your heads that would make this 55 degrees in A here. So the angle is half of the arc, or the arc is double the angle if it's on the edge. Okay? The difference being, if you go back here, if the center is at the circle, then they're equal. So we have a central angle and a central arc, maybe we could call it, versus an inscribed angle is on the edge and an intercepted arc. That's it. Good luck.